All right, in this lecture, we're going to continue looking at conditional probability, but we're going to be looking at a slightly different type of conditional probability. In the past, we've been looking at probabilities that give you the likelihood of a future event, right? So what's the probability of this happening given that this happens, right? So this happens in the future. That would be called an a priori probability, okay? But we might be interested in what's the probability that something happened in the past given some condition presently, okay? And that's called an a posteriori probability, okay? And that's what we're going to be looking at today. So probably the easiest way to look at this is just dive into an example. So in this example, we have 3 machines. We're just going to call them A, B, and C. And they produce similar engine components. And machine A produces 45% of the total components, B produces 30%, and C produces 25% of the components. And in general, we've got some information about the quality of the parts that come out of these different machines. 6% of the parts that come off of machine A do not meet specifications. 4% for machine B and 3% for machine C. Okay, so if one component is selected at random from the output of all these machines and it's found to be defective, what is the probability that the selected component was produced by machine A? Okay, so you can see the posteriori probability, right? We've selected the part, and we want to know in the past what machine it came off of, which machine produced that that part, or what's the probability that it came off of machine A. All right, so but we can write this as a probability that it's just a conditional probability. We're looking for the probability that the machine that produced the component is A, given that it's defective. Okay, and if you remember from last time, we had this formula. We had the probability of A given D is equal to the probability of A and D happening all over the probability of D. Okay, and we're just gonna use that formula. It's the same formula that we already learned. All right, I'm gonna draw a tree diagram because this is a good application of a stochastic process. So I'm gonna draw a tree diagram. So all right, so the first stochastic event is, some machine produced parts, and we don't know which one, so we have some chance event as far as whether the part came off of machine A, machine B, or machine C. Okay, now we're told 45% of the parts come off of machine A, 30% come off of B, and 25% come off of C. Okay, so we can put those probabilities on there. And then we have some information about their quality, right? And we can just, either their part comes off and it's good or it's defective, right? So the next layer in the stochastic process is that the part that comes off the machine is either defective or not defective. Okay, so this is a lot like some of the problems that we were doing in the last lecture. Okay, so each time a part is produced, it's either defective or not defective. Okay, no matter what machine it came off of, but the probabilities are different, right? If it came off of machine A, then there's a 6%, so 0.06% chance it's defective, which means that it's got a 94% chance of being non-defective. 4% chance, if it came off of machine B, there's a 4% chance it's defective, which means that there's a 96% chance that it's not defective. And then there's a 3% chance that a part from machine C is defective, which means there's a 97% chance that it's not defective. Okay, Now, we need to know, you know, the numerator and the denominator here to calculate the probability that the part was produced by machine A, given that it's defective. We first of all need to, well, let's figure out what's the probability in general of being defective, okay? So we can get defective parts in 3 different ways, right? Either it's defective and came off of C, it's defective and came off of B, or it's defective and came off of A, right? So we can compute those probabilities. So to compute the probability that the part came off of A and is defective, right? It's just going to be the product of those probabilities. So 0.45 times 0.06. Okay, so I get 0.027 when I multiply that. The probability that it came off of B and is defective. So we have a 30% chance that it came off of B, and of the parts that came off of B, 4% are defective. Okay, multiply that out, you get 0.012. All right, the last way that it could be defective would be it came off of C and is defective. It has a 25% chance of coming off of, you know, any given part has a 25% chance of that it came off of machine C, and of those parts, 3% are defective. So that gives us a probability of 0.0075 that it came off of C and is defective. So to figure out what's the probability of a part being defective in general, we just need to add up all these probabilities. You know, we need to add up all the different ways it could be defective. Either it came off A or B or C. So we're just going to add up. Let's just put a line here. We're just going to add up all those probabilities. So if I put that into my calculator and I add up 0.027, 0.012, and 0.0075, I got 0.0465. So that's the probability that that a part is defective in general, right? So that's the denominator that we're looking for. And now to figure out what the probability is that the part came off of machine A, given that it's defective, we just need the probability that it came off of, the probability that it came off of machine A, given that it's defective, is the probability that it came off of machine A and is defective over the probability of being defective. Okay, so we're just going to take that, we have that probability here, the probability that it came off of A and is defective. And so that's 0.027, and the probability of being defective is 0.0465. So the probability that that a part came off of A, machine A, given that it's defective, is 0.5806. Okay. All right, so it's basically the same formula. It's the same formula we were using yesterday. It's just that now we're calculating an a posteriori event, the probability of something that happened in the past. Okay, that's the only thing different. And that's all Bayes' theorem is about, honestly. That's it. That's all we're doing. So you can just do it the same way we were doing the other conditional probabilities yesterday. So, but I'm just going to show you this because I think this is sometimes what scares people about math. All right, here's the formula that's in your book. All right, so I'm not going to, do not memorize this formula. I mean, because this is the probability of event A and event E happening. Right, that is what the numerator is. And this denominator, remember we summed up all those probabilities. This is just the probability of event E happening, okay? Because it can happen in any number of ways, right? And so we're just adding up those probabilities. So don't get scared by this formula, because that is an ugly looking formula. But what you need to do is just use a tree diagram and remember this formula right here, that the probability of A given B is equal to the probability of A and B over the probability of B. Okay, that's the key thing. It's really no different than some of the things we were doing in the last lecture. All right, so take a look at this next problem. Give it a try, and I'll meet you in the next video.